Hello and welcome. All right, so we are doing today's learning target. I can express the probability of an event, that should be singular, as a fraction, decimal, and percent. So we're going to learn about probability in this new unit. Remember, expectations, use twice this video to take notes, pause, make sure they're legible and that they're organized so that you can find them later. Part of that organization is using a table of contents. So this is our current table of contents. Hopefully, yeah, there it goes. All right, so right now we're on probability intro, page 11. So then I go flip, flip, flip. All right, I've pre-written some stuff in the hopes that makes this video a little shorter so that you can focus on each of the stills. So this is the beginning. There's the title, probability intro. We're on page 11 and our learning target is up there. I can express the probability of an event as a fraction, decimal, and percent. So this symbol means percent, or part of 100. Per is part of, cent is like century, or there's 100 pennies in a dollar, so 100 out of 100. And so with someone next to you, I realize if you're in the flex space, there's someone next to you, or you can play against yourself and just see what your hands come up with. So you have two people, and I want you to play rock, paper, and scissors. So remember that rock will beat scissors. You don't have to write this. This is just for rules. Scissors beats paper, and then paper beats rock. All right. So with someone next to you, play about 10, make 12, however many you need to, at least 10. So hopefully more than 10. And keep track. So if you have your two hands and one goes rock, one goes paper, that means your left hand if that's A and your right hand if that's B, then B would be winning and you would tally on the B because B won. If you both show the exact same symbol, then that would be a tie. Note that once you get 5 tallies, you go across. So you make groups of 5. That's how tallies work. So I'm just going to make up random numbers and we'll see. 1, 2, 3. And we'll do tying for a lot. We'll just say they really outsmart each other. And I'll do 5 and then 3 and then 4. Why not? We'll do that. Okay, so this is what I'm doing, but pause the video, make sure you have at least 10 different games played and you've kept track of who has won how many of which. Okay. So we are going to find the probability that player A wins. This P stands for probability. This P stands for, and A stands for player A. So this is the probability that player A won a game. So I need to find a part out of a whole. So we're always going to start probability as a fraction, and from there we'll move to the decimal and the percent. We always start probability with the fraction, and then we move to the decimal and percent. So part out of the whole. How many times did A win? A won 8 times. How many total times were played? In my case, there were 8 plus 4, which is 12, plus 5, which is 17. So 8 is how many times A won. 17 is how many total games were played. So this is the probability or chance that A would win as a fraction. Notice this is under the category experimental probability. We are doing an experiment. We ran the experiment 17 times, 8 times A won. So we're actually doing it and coming out with some results or some data. So this is the fraction. So we're going to label this as fraction. All right. Then we also want a decimal and we also want a percent. So we're going to be using our calculators for this. So remember, fractions are just division. Fractions are just division. So I'm going to take 8, I'm going to divide it by 17, and I get this. So we're going to say this is 0.47. and I'll just stop there at the hundredths place because that'll help me for percent. So notice this 5, it would round the 0 up, but I'm not going that far. Since this 0 is so small, it's not going to round my 7 up, so I'm going to stay at 4/10 and 7/100. So that's going to then mean if I multiply this by 100, that's my percent. So if I multiply by 100, that gets me the percent of 47%. And you can't see that. There we go. So I multiply my decimal by 100, and that gives me my percentage. So this is probability that A will win. The chance that A wins my games will be 8/17, or that's 47/100, or 47%. Okay? What if, change color here, what if I want the probability that B wins? Again, it's part over whole. So what's the part that B won? B won 4 of the games out of a total of 17. That's the fraction. Now I'm going to use my calculator to figure this out as a decimal. So 4 divided by 17. And again, you have calculators on your computers. So my decimal, so this is equal to 0.24. Notice that this 5 over here, oh, no, you disappeared. 4/17. Notice this 5 over here is 5 or greater. It's big enough. It rounds this 3/300 up, so it makes it 24/100. Now I'm going to then multiply that by 100, and you should end up with then 24%. Okay? Basically, you're moving this decimal point just 2 places. That's what multiplying by 100 does. So the chance that A wins is 47%. The chance that B wins is 24%. And what's the chance that you play a game of rock, paper, scissors? Like, what's the biggest percentage you could ever have? What's the largest chance anything can have has ever happened? What's the largest chance that anything that's ever going to happen has? 100%. So notice when we do the probability of ties, there were 5 games out of 17 that were tied. So if I do 5 divided by 17, notice that this gets me 29% because that 4 does not round it up. So this is 29 and 29%, okay? And now, if I add them all up, I can check myself. So when I add them up, I should have 47% plus 24% plus 29%. Add them all up. Pause the video and add them. You should end up with, that's 13 plus 7, which would be 20, and that should make 100, because that'd be 10. You should end up with 100%. Okay? Even if you round up on one, you'll be rounding down on another one, so that should make it 100%. Sometimes it's a little wonky because of the rounding issues, but you should be around 100%. All right? And if you're not, come ask me questions and we can clarify that and work through it. Okay, so theoretical probability is our next piece. I'll just go to there. Okay? Theoretical probability is our next piece. So experimental is where you're actually doing the battles between rock, paper, and scissors. But theoretical is just, what if? Like, this should happen proportionally as we go through. Proportionally. Hoo, 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 hoo. Using our Unit 1 terminology. Okay, so imagine you have 2 people, A and B. If A throws a rock and B throws rock, who wins? Or is it a tie? It's a tie. So I'm going to put a T there for tie. If A throws paper and B throws rock, who wins? A wins because paper will win. So I want you to go through this table, pause here, fill it out, who would win or who would tie. You should end up with this. Okay. So in this hypothetical situation, hypothetical is the big key for theoretical. We haven't actually done rock, paper, scissors. This is all hypothetical. How many games were hypothetically played? Count them up. There are only 9 games played. So in this situation, I'll change my color again. Why not? No, I won't. I'll go back to green. Okay. Yeah, I'll change my color. We'll be consistent. Okay, so probability of A winning. How many of those 9 games did A win? 3. Okay? We can simplify this to 1/3. If you ever have a fraction that you can simplify, you better. I did not simplify these because I can't simplify 17. There's nothing that can go into both of them. But I can divide 3 by 3 and 9 by 3, and that gets me 1/3. As a decimal, you'll find it should be 0.33. As a percent, it will be 33% because those 3's do not round up. What about probability that B wins? Of these theoretical games that did not actually happen, hypothetically, how many games did B win out of how many? B would have won 3 out of 9 as well. So keeping the same numbers. And then I need green. And then probability of ties. I want you to pause the video, complete that one on your own. Okay, so you're seeing the pattern here. Should be 3/9 equals 1/3, which is 33/100, or 33%. All the same thing. Now notice we can check ourselves here to make sure we got every single combination. I'm going to add 33% with 33% with 33%. You're going to notice this only adds up to 99%, which is a little off from the 100 we want, but that's just because this is technically 33 1/3, and that extra third, and third then makes the 1% we're missing, but that means we're still good. If you get 99% because of rounding issues, that's okay. So theoretical is information or chances of these events of A winning or B winning or a tie. Those events that actually happened or did not happen are theoretical. If the chance of them in the future happening would be theoretical. Experimental is we've actually done the experiment. This is how many times we did it. This is how many times it happened. So going on the random information I created, this one's the closest to 33% that we would expect. 24 is a little low and A is 47 is a little high. So this is what we should expect is 33, 33, and 33. Looking at your data, how far off were you? Were you around 33? Or were you higher or lower? Did you outsmart your opponent more? Or did you both think the same and you get a lot of ties? Okay, last piece. Last 2 examples. So it's 4 examples with 1 set. Ignore the scribble. So write down the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. How many numbers are here total? Part over whole. There are 9. All right. So for all of these, we're going to be dividing by 9 because that's the total. Dividing by 9. Dividing by 9. Dividing by 9. Because that's the total. Now I want to look at the probability of choosing a 6. If these numbers were scrambled up in a hat, you pull one out randomly, how many of those possibilities are the number 6? 1. So 1/9 is our fraction. Going through this again, what's the chance of drawing an odd number? If you draw from this hat, how many of these are possibilities of being an odd number? There's 1, 2, 3, 4, 5. 5 of these are odd numbers. What's the probability that it's a number less than 3? How many of these are less than 3? Only 1 and 2 are less than 3, so there's only 2 possibilities. And then the probability of hitting a 7 or an 8. That means there's only 2 options, a 7 or an 8. Either one would work, but I have only 2 options. So also that is 2/9. Now to find our decimal. So let's do 1 divided by 9. Okay, so this should be 0.11. 5 divided by 9. 0.56. Notice that 5 rounds the other 5 up. And 2/9. All right, pause here. Can you write them all as percents? Where's my mouse? There's my mouse. Can you write them all as percents? You should end up, there we go. I have too many rolling markers. As 11%, 56%, 22%, 22%. And we're done. All right. And after the video, making sure, did you focus? Did it make sense? And we'll do more exploration with us once we get back to the classroom. Have a great day. Bye.